Somewhere out there, right now, the sun is shining. On the other side of the world, or low on some horizon, or straight overhead, pouring out light the way it has every single day of your life, and every day of every life before yours, steady and warm and utterly reliable. You felt it 1,000 times, the warmth of it on your face on a cold morning, the way it fills a room, the most ordinary thing there is. And there's no hurry in any of this. We have the whole night, and the mystery we're going to follow has waited 100 years to be understood. It can certainly wait for you to breathe. So let's not rush toward anything. Let's just wade slowly down into it, the way you'd wade into still water, letting each part of you get used to the depth before the next. If your mind wants to race ahead to the answer, let it tire itself out and drift back. There is nothing here you have to catch and nothing you have to keep. And I'll tell you honestly, this is one of my favourite things to think about as I'm falling asleep. This exact idea, the strangeness underneath the sunlight. Because it takes the world that felt so hard and fixed and demanding all day, and it shows you that the hardness was only ever the surface. That underneath, the whole thing is loose and alive and humming quietly to itself, and far more astonishing than it ever let on. It's a good thing to lie down inside of. I hope by the end it will be for you too. And here is something I find quietly astonishing, and it's where I want to begin tonight. For a long time, well into the last century, nobody could explain how the sun manages to shine at all. Not vaguely, precisely. The best physicists in the world did the arithmetic on how the sun makes its light, and the arithmetic said it shouldn't be able to. That by every rule they knew, the process that lights the sun simply could not happen. And yet there it was, and here we are, warmed by it. Something was missing from the picture, something deep. And when they finally found what was missing, it turned out to be one of the strangest and most beautiful facts we have ever discovered about reality. A fact that reaches all the way down to the smallest pieces of the world and all the way out to the stars. And it turns out straight through you. The reason the sun can shine is bound up with the reason the universe, at its very foundation, can never be pinned down, can never be nailed to a single sharp point, can never be made to hold perfectly still. I know that might sound like a strange place to find comfort. We usually want the opposite. Things nailed down, certain, fixed and settled and known. Uncertainty in ordinary life is the thing that keeps us up at night, not the thing that puts us to sleep. So it's a real turn to discover that at the very foundation of reality, uncertainty isn't a problem or a threat. It's the quiet, load-bearing gentleness that lets everything exist. It's what lights the stars and holds the atoms open and stirs faintly in your own hands. And there's a particular wonder in meeting it that way. Not as an enemy to be conquered, but as the soft, strange, generous thing that has been holding you up all along, and that you get tonight to lie down and marvel at. That's where we're going tonight, slowly, together, down beneath the warm and solid surface of things to the strange, soft foundation the whole world is built on. The place where matter refuses to be located exactly, refuses to be fixed, and in that refusal, somehow lights the stars and holds you together and makes it possible for there to be anything here at all. We're going to follow a mystery, a real one, the one that stumped everyone, all the way down to its answer. And I think when we come back up, you won't feel small, the way these cosmic things sometimes make us feel. I think you'll feel something closer to wonder. The strange good fortune of being here, a warm and thinking thing briefly on top of something this staggering, and getting to know even a little of it before you sleep. You don't need to follow every step. If a piece slips past you, let it slip. This isn't a lesson, and there's nothing you have to hold on to. If you fall asleep before we reach the end, before we even reach the sun's secret, then you've gone exactly where this was always headed, only sooner, and the answer will keep until another night. And I'll make you the promise I always make. Wherever this seems to be going, we end somewhere restful. I wouldn't walk you out to the edge of the strangest thing in physics and leave you standing there. So you can loosen your grip on understanding all of it. You already know how the night ends. It ends with you asleep. Let your shoulders drop from wherever they've been holding. Let the back of your head grow heavy against the pillow. There is nowhere you need to be, and nothing you need to solve, and no part of you that needs to stay sharp and ready. The sun will shine tomorrow whether or not you work out how. Tonight you only have to lie still and wonder and drift. Let me tell you what the sun is actually doing when it shines, because the mystery only becomes wonderful once you see how it shouldn't work. The sun makes its light deep in its core by taking the smallest, simplest pieces of matter, the tiny cores of hydrogen atoms, and pressing them together so hard that they merge into something new, releasing a flash of energy each time. Do that unimaginably many times over, every second, and you get sunlight. That merging, that fusing of small things into slightly larger things is the furnace at the heart of every star. It's the source of nearly all the light in the universe. It's the reason there is warmth anywhere at all. But here is the trouble, the one that stumped everyone. Those little cores all carry the same kind of electric charge, and things with the same charge push each other away. You've felt this if you've ever tried to press the wrong ends of two magnets together. That invisible cushion that only gets firmer the harder you push. The closer two of these cores get, the more furiously they shove each other apart. And to merge, they don't just have to get close. They have to get close enough to practically touch, through a wall of repulsion that grows more violent with every step. Picture it for a moment, slowly, because the strangeness lives in the details. Two of these tiny cores racing toward each other in the furnace at the heart of the sun. As they close the distance, the push between them stiffens, gently at first, then harder, then ferociously, a rising wall of resistance that wants nothing more than to turn them back. It's a bit like rolling a ball up a hill that gets steeper and steeper toward the top. If the ball is moving fast enough, it crests the hill and rolls down the far side. The cores touch, they merge, a flash of light is born. If it isn't moving fast enough, it climbs part way, slows, stops, and rolls back down. No merging, no light. And the higher the hill, the more speed you need to clear it. So the whole question of whether the sun can shine comes down to a simple contest. How high is the hill of repulsion between two cores, and are the cores moving fast enough to get over it? And physicists measured exactly that. They worked out how hot the sun's core is, which tells you how fast the cores are really moving in there, how hard they're slamming together, and they compared it to the height of the hill, and the numbers said something that should have been the end of the whole story. The cores are not moving anywhere near fast enough, not close, not almost. They arrive at the bottom of that hill of repulsion with a small fraction of the speed they'd need to climb it. And so, by every rule of the ordinary world, they should roll partway up, stop and come back down. Bounce off, turn back, never touch. The merging that lights the sun should almost never happen. The sun should be dark or very nearly, and instead it blazes, and has blazed for billions of years, warm enough to have grown an entire living world beneath it. Imagine being one of the physicists who first ran into this. You've spent your life learning the rules of how matter moves, and they work. They work beautifully. They've explained 1,000 things, and you turn them on the most obvious, most reliable object in the sky, the thing that has been shining over every human being who ever lived. And the rules tell you flatly that it can't be doing what it is plainly doing, that the sun should not shine. There's a particular kind of vertigo in that, not the thrill of discovering something new, but the deep unease of your trusted rules failing at the one place they most obviously shouldn't. It meant something was missing, not a small correction, not a rounding error. Something fundamental about how the smallest pieces of the world behave. Something no one had yet grasped, hiding in plain sight inside a sunbeam. Something was letting those cores through a wall they did not have the strength to climb. Something the old physics knew nothing about. And to find it, physicists had to stop looking at the sun and start looking at the very smallest pieces of the world. Because whatever was happening down there, in the strange behaviour of the tiniest things. Down at a level where matter, it turns out, does not behave anything like the solid, sensible stuff of the daytime world. That's the thread we're going to follow down tonight. Not because you need to solve it. You can let the whole puzzle go and simply drift if you like. But because the answer, when it comes, is so much gentler and stranger than anyone expected. The thing that lets the sun shine is the very same thing that keeps the atoms in your body from collapsing. The very same thing that means nothing in the universe is ever perfectly still. It's all one fact, one soft and astonishing fact about the bottom of the world, and we're going to walk all the way down to it and then let it carry us to sleep. And I love that the door into it is the sun. Not some obscure laboratory curiosity, some effect you'd only ever meet in an experiment, but the most familiar, most reliable, most taken for granted thing in the sky. The thing that has warmed every morning of your life. It turns out that if you look closely enough at why it shines, you fall straight through it into the deepest strangeness there is. That's often how it goes with the very deepest things. They aren't hidden away in far corners. They're sitting inside the most ordinary experiences we have, waiting patiently for someone to look closely enough to fall through. So let's go down, slowly. There's no hurry at all, toward the smallest things there are, and how little they resemble what we imagine. To understand what those little cores are doing, we first have to let go of a picture in our heads, the picture of the smallest pieces of matter as tiny balls, tiny hard specks, little pebbles too small to see, bouncing around like impossibly small marbles. That picture is comfortable, and it's wrong, and setting it down is the first soft step down into the real strangeness. Take the electron, one of the simplest little pieces there is. In some ways it does behave like a tiny pebble. It comes in lumps. You never find half an electron, or an electron smeared thinly across a room like a mist. When you catch one whole, countable thing. 1 electron, 2 electrons, 3. So far, very pebble-like. But in other ways, it behaves like nothing you could ever call a pebble. Send a stream of them through the right kind of arrangement, even one lonely electron at a time, so slowly that there's never a crowd to jostle. And something happens that no pebble would ever do. Each one arrives and leaves a single small mark, just where you'd expect a little speck of matter to land. But let the marks build up, one by one, over a long while, and they don't gather into the simple heap you'd get from throwing sand. They arrange themselves, mark by patient mark, into a pattern of ripples, bands of many marks, and between them bands of almost none. Bright and dark, exactly the pattern you get when waves overlap, reinforcing in some places and cancelling in others. Grains of sand do not do that. Tennis balls do not do that. Only waves do that. And yet each electron arrived alone, as a single countable lump. So this thing that comes in pebble-like pieces somehow travels and spreads and ripples and interferes with itself along the way, like a wave. So which is it? A wave or a particle? And this is the question that tied everyone in knots, because the obvious answer, that it must somehow be both at once, doesn't quite work either. It isn't a little pebble that sometimes turns into a wave and back again. The honest answer, the one it took the sharpest minds years to accept and make peace with, is stranger and simpler than that. It is neither. It is a third kind of thing. Not a wave, not a particle. There's a lovely way to feel this. Imagine an animal that flies and has wings, but also has soft fur and a small warm face like a mouse. You wouldn't say it was a bird and a mouse at the same time, some impossible creature flickering between the two. You'd simply say it was its own animal, a thing in its own right that happens to share a wing with one and a face with the other. That's the electron. It shares the lumpiness of particles and the rippling of waves, and it is neither. Physicists gave the whole family a plain name, quantum objects, and mostly stopped trying to force them into the old boxes. And there's a quiet wonder in that alone, which I've always loved. For a long time we assumed the world had to be made of the things we already had words for, and the world, very gently, said no. It is made of something we'd never met, something that fits neither word, that we had to invent a new name for, and learn to accept on its own terms. The universe was under no obligation to be describable in the language we brought to it. It simply is what it is, stranger and more itself than our tidy categories, and it waited, patiently, for us to stop insisting and start looking. And there's something almost tender in how these little things behave once you stop demanding they be pebbles. They come to us in whole, countable pieces. You always catch one, never a fraction. And in that they're humble and definite, like the plainest matter. And yet, between one place and another, unwatched, they spread and ripple and explore in a way no solid speck ever could, as if the moment we aren't pinning them to a spot, they remember there's something freer. It's a strange double nature, definite when it lands, open and wave-like on the way. And all of the softness we're about to explore, the whole reason the world can't be pinned down, grows out of that second, freer, wave-like side. The side that only shows itself when nothing is forcing it to be exactly somewhere. And here's the piece that will matter most as we go down. So let it settle in gently. Because a quantum object has this wave-like side, there is a wave tied to the way it moves. This was one of the boldest guesses anyone ever made by a young French physicist named de Broglie in the early 1920s. Light, everyone had recently learned, could arrive in little lumps as well as spread like a wave. And de Broglie, thinking about this in the quiet way that leads to the biggest leaps, asked, if light, which we thought was a wave, can also be a particle, then perhaps matter, which we thought was made of particles, also has a wave side. Perhaps electrons too have a wavelength. It was a wild thing to suggest, with almost no evidence, nearly pure intuition, a sense that nature ought to be symmetrical. And the beautiful part is that he was right. Within a few years, experiments confirmed it. Electrons really do have a wavelength, really do ripple and interfere, exactly as he'd guessed. I never quite get over that. The idea that a person can lie awake or sit quietly with a piece of paper, following nothing but a feeling about how the world ought to fit together, and reach out and touch something true that no one had ever seen. There was no experiment telling de Broglie that matter had a wave side. There was only a sense of symmetry, an intuition that the universe was too elegant to make light a wave and particle while leaving matter merely a particle. And the universe, when we finally checked, agreed with him. This is often how the deepest truths in physics arrive, not from a machine, but from someone following a quiet hunch about the shape of things, and being met, astonishingly, by a world that turns out to be built that way. It's a reminder that the strangeness we're walking through tonight was first glimpsed not in a laboratory, but in the stillness of a thinking mind. And the bridge he built is the one we'll cross in a moment. The way a quantum object moves, its momentum, its push through the world, is tied directly to its wavelength, to how stretched out or bunched up its wave is. A long, lazy, stretched wavelength means one amount of motion. A short, tight, bunched one means another. Motion and wavelength, welded together, two names for a single fact. Change one, and you have already changed the other. This is the quiet little fact the whole night turns on, so let it sink in without any effort. In the ordinary world, the motion of a thing and its shape have nothing to do with each other. A ball's speed is one matter, its size is another. You can change the one and leave the other exactly as it was. But for a quantum object, motion and shape are welded. Its motion is its wavelength, is the stretch of its ripples. So anything that pins down its motion pins down the stretch of its wave, and anything that changes the stretch of its wave changes its motion. They are not two things that happen to travel together. They are one thing, wearing two faces. Keep that near you as we go down. It's the hinge and everything swings on it, including in the end the shining of the sun. Now we come to the heart of it, the fact that will answer the sun's mystery and everything after. And I'll take it slowly, in small pieces, because once you feel it, it stops being a rule you're told and becomes something you can see, something that couldn't possibly be any other way. No formula to hold, just a picture, built up gently, one layer at a time. Start with motion. Suppose you wanted one of these objects to have a perfectly definite motion, one exact amount of push, no vagueness at all about where it's headed. We just said motion is written in the wavelength, so a perfectly definite motion means one single, pure, exact wavelength and no other. Picture that wave, a pure wave of one single wavelength, smooth even, every ripple identical to the last, rising and falling in perfect repetition. And here's the thing about a pure wave like that. It never ends. It can't. To hold one exact wavelength everywhere, it has to go on rippling evenly forever, out to infinity in both directions, the same all the way. A pure, endless tone that never begins and never stops. Now ask the question that changes everything. Where is it? Where is this object located? Look, the wave is spread evenly across all of space, the same rippling everywhere, no place any different from any other. There's no peak, no bump, no here rather than there. It is, in the fullest possible sense, everywhere, which means nowhere in particular. Go looking for it, and it could turn up absolutely anywhere in the universe, no spot more likely than any other. Sit with what just happened, because it's the whole secret in miniature. We asked for perfect motion, one exact wavelength, and in exchange the universe handed us complete vagueness about location. Not because we measured clumsily, not because our instruments were crude, but because a wave with one perfect wavelength simply is a wave spread across everything. The two facts are one fact, seen from two sides. Perfect sharpness of motion doesn't cost you the position. It comes bundled with a thing that has no position, built right into the shape of what a pure wave is. Let me say it once more, gently, from a slightly different angle, because it's the kind of thing that only really lands on the second or third pass and there's no hurry at all. We didn't lose the position. There was no position to lose. A perfectly pure wave, one single, endless wavelength, is a thing that exists evenly everywhere. And a thing that exists evenly everywhere is a thing with no particular here. The perfect sharpness of its motion and the complete openness of its whereabouts are not two separate facts that happen to arrive together. They are one fact, seen from two sides, sharp in the motion all the way, and the location doesn't get a little vaguer, it opens completely to the whole of space at once. That is what a perfectly definite motion is down here, a thing that is everywhere. And I find there's something almost dizzying and lovely in that, worth pausing on. In the everyday world, to know a thing's speed exactly and to know its place exactly are two separate errands, and doing one doesn't touch the other. Down here, they've become almost like two ends of a single seesaw. Press one end all the way down, perfect motion, and the other end swings all the way up. No location at all, spread across the entire universe. There's no setting where both ends rest level and sharp together. The seesaw simply won't hold that pose, and it isn't a flaw in the seesaw or a limit on how carefully we can look at it. It's the shape of the thing, motion and place, forever trading against each other, forever unable to both be pinned at once. Well then, you might think, let's do the opposite. Let's build something that's in a definite place. And we can, but watch what it costs. To get a wave bunched up in one location, instead of spread across all of space, there's really only one way. You take not one pure wave, but several, each with a slightly different wavelength, and you lay them over one another. And something wonderful happens. In most places, the waves are out of step, one rising while another falls, and they cancel toward nothing. But in one region, they can all line up, all peaking together, swelling into a single tall bump. Everywhere else, cancellation, flatness. In that one spot, a peak. You've made a little bundle, a wave packet, that's actually somewhere. It has a location now. Pile on more and more waves of more and more slightly different wavelengths, and you can squeeze that bundle tighter and tighter, more and more sharply located, until it's very nearly a point. It's worth picturing this slowly, because it's genuinely lovely to watch in the mind's eye. Start with one endless, even wave, spread across everything. Lay a second one over it, a touch longer or shorter. Now, in the places where their peaks disagree, they start to cancel. And in the one place where their peaks agree, they swell. Already, the even, everywhere the same wave has grown a slight bulge in the middle and thinned at the edges. Add a third wave and a fourth, each a little different, and the bulge sharpens and the edges flatten, the way many voices, most of them out of step, will mostly cancel into a murmur, while in one moment they all land together and swell into a single clear sound. Keep going, adding more and more, and the bundle draws itself in tighter and tighter. A little gathered heap of wave, quiet everywhere, except in one small place, where it stands up sharp and clear. You've built a location out of pure motion by blending motions together, and the more precisely you want that location, the more different motions you have to pour in. But feel what you had to do to get there. To make it located, you had to blend together many different wavelengths, and wavelength is motion. So an object built from many wavelengths is an object carrying many different amounts of motion at once. Its motion is no longer one clean value. It's a spread, a smear, a whole range of pushes bundled together. The very thing you did to give it a sharp place is the thing that blurred its motion, and the tighter you squeeze the location, the more wavelengths you need, and the more smeared the motion becomes. And isn't it lovely that it comes out of something so simple, not from some strange extra rule bolted onto the world, some arbitrary law handed down that things must be uncertain. It comes straight out of what a wave is. Waves, ordinary waves, the kind you've watched on water your whole life, simply have this property. To make one that's sharply located, you must blend many wavelengths together. To have one pure wavelength, it must spread out endlessly. That was always true of waves long before anyone knew a thing about quantum objects. And once the world turned out to be built, at the bottom, from these wave-like things, the softness came along for free. Not added, not imposed, just a natural consequence of a world made of waves. The uncertainty was hiding inside the nature of waves all along, waiting for us to notice it was also the nature of matter, and of the sun, and of us. There it is, the whole principle built with your own hands. A sharp position needs many wavelengths, which means a blurred motion. A sharp motion needs one wavelength, which means a spread out, placeless thing. You cannot have both sharp at once, not because you lack the tools, but because a thing that was sharp in position and sharp in motion together simply cannot be built out of waves. And everything down there is built out of waves. So there is no such object to find. It isn't hidden from us. It isn't there to be hidden. And if that still feels abstract, here is a way to actually hear it, because this same trade lives in sound, and you already know it in your body, even if you've never named it. Sound is made of waves too, and the very same rule holds. Think of a single, pure, sustained musical note, a long, clear tone, held steady, going on and on. That tone has a very definite pitch. You could name it exactly. And notice what a pure pitch requires. It requires the tone to be held evenly for a good long while. A perfectly definite pitch would need a tone that never begins and never ends. So the purer the pitch, the more it must be smeared across time. Ask exactly what note it is, and you lose track of exactly when it happens, because it happens across all of when. Now think of the opposite, a single sharp sound, a click, a tap. Its position in time is beautifully sharp. You know exactly when it landed. But ask what pitch it was, and you can't say. A click has no clear pitch at all, just a burst of every pitch at once. To be sharp in time, it had to blur its pitch. It is the very same principle playing out in music. The long, clear note that fills a span of time, the short, sharp tap that has no tune. That trade you've heard your whole life is the uncertainty principle. Position and motion, pitch and moment, the same law everywhere waves are. And that's what Heisenberg captured in the principle that carries his name, worked out, remarkably, by a very young man, some of it during a stay on a bare, wind-scoured island in the North Sea, where he'd gone to escape a bad bout of hay fever, walking the rocks with his mind full of a mathematics no one had used this way before. Take the vagueness in position and the vagueness in motion, multiply them together, and you can never get below a certain small floor. Push one down, and the other rises to keep the product above the line. Trade them against each other all you like, a little sharper here, a little blurrier there, but you can never get them both to zero. The floor is built into the world. It is not a statement about what we can know, it is a statement about what there is. And notice how different that is from where we started this part. We could have been forgiven for thinking the blur was in us, in some crudeness of our looking. But having built the thing up from waves with our own hands, we can see plainly. There is no hidden sharp truth. A thing that is perfectly sharp in position and perfectly sharp in motion at once is not a thing that's hard to find. It is a thing that cannot be built out of waves at all. And everything down here is built out of waves. So it isn't out there waiting, just beyond our reach. It simply isn't. The unpinnableness isn't a curtain drawn across a sharp world. It goes all the way down. There is no sharper floor beneath it. This is the floor. And let me clear away quickly the way this usually gets explained, because the usual way robs it of its wonder. You may have heard that uncertainty is about clumsy measurement, that to find a tiny thing you have to bump it, and the bump disturbs it, so you can never catch both facts at once. It's a natural thing to think, and it is not what's happening. What we just built has nothing to do with bumping, or disturbing, or the crudeness of our tools. It was there before anyone measured anything. A perfect, gentle, all-seeing eye that disturbed nothing at all would find exactly the same thing. A world that, at the bottom, does not carry a sharp position and a sharp motion at the same time. The blur is not in our looking. The blur is in the thing, and that is far stranger and far more wonderful than any story about clumsy hands. I want to stay here a moment, because it's the turn the whole night rests on, and it's worth letting it land. Every ordinary way of thinking puts the blur in us, in our crude tools, in the limits of our knowing. It says the electron really does have a definite place and a definite motion, a sharp true answer sitting there, and we're just too clumsy to read both at once. A story about human limitation, in which the sharp truth waits patiently to be uncovered by someone cleverer. And what we just saw is that this gets it exactly backwards. The sharp answer isn't hidden. It isn't there. There is no tiny pebble sitting at a definite point with a definite velocity, coyly refusing to show us both. There is a spread. The spread is the thing. When one of these objects is bundled into a place, the range of motions it carries isn't our ignorance about its one true motion. It genuinely carries that whole range, all those wavelengths woven into what it is. The vagueness isn't a veil over a sharp reality. The vagueness is the reality. It's worth staying here a moment, because our whole daytime instinct fights this, and the fighting is tiring. All day the mind assumes everything has a definite answer somewhere, and that not knowing is a failure, a gap to be closed, a fact we simply haven't tracked down yet. Where exactly is it? How fast exactly is it going? The mind treats every blur as a problem, waiting for a sharper look, and that's a fine way to move through the ordinary world of tables and roads, where things really do have definite places and the blur really is just our not having checked. But down here, at the foundation, that instinct simply doesn't apply. Down here, there is no sharp fact hiding behind the blur, no exact answer kept just out of reach. The blur is the answer. The softness is the truth of the matter, whole and complete. There is nothing further to find, nothing you're failing to see. You have already seen it clearly the moment you accept that it is soft. And I want to be honest with you, the way this channel tries to be, physicists still discuss what this ultimately means in the deepest sense, and there are real disagreements about the full picture that I won't pretend are settled. But about the thing itself, that these objects carry a genuine spread, that the trade between position and motion is built into their nature and not into our instruments. About that, there is no controversy at all. It is as solid as science gets. It has been tested every way anyone can devise for the better part of a century, and it has never once failed. And I find even that mix, near total confidence about the fact, genuine open wonder about its deepest meaning, is itself a kind of marvel. Here is something we understand well enough to build the whole modern world on. Every computer chip, every laser, every scan in every hospital leans on this physics working exactly as described. And yet, at its very deepest level, it still holds a mystery the wisest people alive haven't fully resolved. It's a reminder that you don't have to understand a thing all the way to the bottom to be amazed by it or to rest in it. We use this softness, we rely on it, we're made of it, and we still can't say the last word about what it ultimately is. And that's all right. Not everything has to be pinned down to be trusted or to be wondered at, especially not tonight. And here is why that turn matters so much for tonight, and why it fills me with something closer to awe than to unease. If the unpinnableness were merely in us, a limit on our knowing, it would be a small sorrow, a door we can't open, but it isn't in us. It's in the world, which means we are not standing outside a locked room, frustrated. We are standing inside the most astonishing fact, that reality at its foundation is not the hard, fixed, clockwork thing it pretends to be up here in the daylight. It is something looser and more alive and more mysterious than that, and we get to know it. A warm little arrangement of that very same unpinnable stuff lying in the dark, somehow able to look down into its own foundations and be amazed. That is not a small thing to be. That is a staggering thing to be, and it changes the whole feeling of the fact, doesn't it? If the uncertainty were a limit on our knowing, a door we couldn't open, it would leave a small ache, a sense of something forever withheld. But it isn't a limit on our knowing. There's nothing being withheld. We can see the whole truth of it clearly. The world is soft at the bottom, genuinely, honestly soft. And that softness is not a gap in the picture, but the deepest thing the picture contains. So there's no ache in it. There's only wonder, the plain astonishment of finding that reality is stranger and gentler and more alive than it ever let on, and that we're here, made of it, briefly able to know. The not knowing was never the point. The knowing is the marvel. And now we can go back and answer the mystery we started with. Why the sun shines when it shouldn't. Because the answer is this same fact, and once you see it do this one job, you start to see it everywhere, holding the whole world up. Remember the trouble. Those little cores in the sun's heart arrive at the wall of repulsion without nearly enough speed to climb it. By the old rules, the rules where every core is a sharp little pebble sitting at a definite point, they should bounce off every time, and the sun should stay dark. But the cores are not sharp little pebbles at definite points. They are quantum objects, carrying that same spread of position we've been exploring all night, that same refusal to be pinned to an exact spot. And so a core approaching the wall does not have one sharp location that either clears the wall or doesn't. It is a little spread out, a little uncertain about exactly where it is, and in that spread, some small part of the time, it finds itself already on the far side of a wall it never had the strength to climb. It doesn't go over. It was never sharply located enough to be stopped by the edge. Through the softness of its own position, it slips across. Physicists have a name for this, they call it tunneling, and it is one of several things a star needs, but without it the sun could not shine at all. It happens precisely because these little pieces of the world cannot be pinned to a point. The very same unpinnableness we built up from waves, the very thing that seemed like nothing but strangeness in the basement of physics, that is what lets the stars burn. Every warm morning you have ever felt, every ray of light that ever fell across a room, all of it reaches you because reality, at the bottom, cannot be nailed down. Sit with that for a moment. The softness at the foundation of the world is not some idle curiosity. It is lighting the sky, and I want you to feel how the whole mystery has quietly turned over. We started the night with a puzzle that looked like a failure. The sun shouldn't be able to shine. The cores are too slow. The wall too high. It seemed like something was broken or missing or wrong. And the answer, when it came, wasn't a patch on a broken picture. It was that the picture itself was too hard, too sharp, too sure of where everything was. The cores get through not by being stronger than we thought, but by being softer than we thought, by not quite having a location, by carrying that gentle spread that lets a little of them already be on the far side of a wall they never climbed. The thing that looked like a problem was the answer all along. The sun shines not in spite of the world's refusal to be pinned down, but because of it. And think for a moment how much rides on that. If the smallest pieces of the world were the sharp little pebbles we imagined, sitting at exact points with exact motions, the sun could not shine. The cores would bounce off that wall of repulsion every time, and the star would stay dark. No sunlight, no warmth, no slow green world growing up beneath it. No you. The entire lit and living universe hangs on this one gentle fact. That matter, at the bottom, is too soft-edged to be stopped by a wall it cannot climb. Take away the softness, make the world perfectly sharp and definite the way our daytime minds expect, and the lights go out everywhere. It's a strange and moving thought to hold, lying in the dark, that the warmth you felt from the sun your whole life reached you only because the universe, at its foundation, refuses to be pinned down. The softness isn't a flaw in an otherwise solid world. The softness is why there's any light to see by at all. And once you've seen it like the stars, you find it holding your own body together too. Think about a single atom, a tiny nucleus at the centre, and the electrons around it. Opposite charges pull toward each other. So here is a question that tormented physicists a century ago. Why don't the electrons simply fall in? Why doesn't the electron spiral straight down into the nucleus and stick, and the whole atom collapse to a tiny dense speck? By the old thinking, it should. Every atom in the universe should have crumpled to nothing long ago. And yet here they all are, holding their size, keeping the world apart and giving it volume. Here you are, made of them. Why? The same softness. Suppose an electron did try to fall in, to settle onto the nucleus, into a tiny exact, pinned down spot at the very centre. To be squeezed into so small a space is to have a very sharp position, and we've seen what a sharp position costs. A wildly blurred, wildly spread motion. Squeeze the position toward a point, and the motion has to blow up to enormous, roaring uncertainty, and that furious motion flings the electron right back out. It cannot settle. It cannot be pinned to the centre, because being pinned to the centre would demand a sharpness the universe does not allow. So the electron keeps its distance, spread into a soft cloud around the nucleus, held at arm's length by the very refusal to be pinned we've been following all night. And that gentle standoff is what gives the atom its size, which gives matter its solidity, which gives you a body and a bed and a floor in the morning. Think about what that really means, lying there. The reason your hand doesn't pass through the mattress, the reason the floor holds your weight, the reason there's any bulk or substance to the world at all. It isn't that matter is packed hard and solid. It's almost the opposite. It's that every atom is holding itself gently open, kept roomy and spread by this refusal to collapse to a point. The solidity you lean on all day is not hardness. It's a vast, quiet standoff. Countless electrons in countless atoms, each one softly declining to be pinned to the centre, each one keeping its atom open and full of space. The whole solid world is built out of that gentle refusal. You could say the world is solid because it's soft, because its smallest pieces will not be nailed down, and that has been true of every atom in you, and in everything you have ever touched, every moment of your life. There's a strange comfort in picturing it. Right now, every atom in your body is doing this. Countless electrons, each one softly declining to fall to the centre, each one keeping its little atom open and full of space. All of them together, holding the shape of you against the dark. You don't have to tell them to. You never have. Through every day of your life, awake or asleep, thinking about it or not, they have simply gone on holding you gently open, by this one quiet refusal to be pinned. They are doing it now, as you lie here, and they will do it all through the night while you sleep, and be doing it still when you wake. You are held together by something that never rests, and never asks anything of you, a soft, tireless, patient standoff, humming quietly beneath everything you are. Let that turn all the way over, because it's the thing I most wanted to bring you. What holds the world together is not something hard. We imagine that whatever keeps reality standing must be some rigid iron law clamping everything in place. And it's the opposite. What holds the world together is a softness, a refusal, all the way down, to be nailed to a point. If the universe could be pinned down, it would collapse. The atoms would fall inward. The stars would go dark. It is precisely because reality cannot be fixed and made sharp and still that there gets to be anything here at all, spread out and stable and roomy enough to hold a night and a pillow and you. You are not held together in spite of the uncertainty. You are held together because of it. There's a quiet reversal in that worth resting on. We tend to think of gentleness and softness as fragile things, the things that give way, that don't last, that need something harder underneath to hold them up. And here, at the very bottom of everything, it's the reverse. The softness is the strong thing. The refusal to be pinned is what endures. The atoms have held themselves open by this gentle refusal for the entire age of the universe, and will go on holding for ages more. Hardness would have collapsed long ago. It's the softness that lasts. So the most dependable, permanent, load-bearing fact about the whole world turns out to be a kind of gentleness. And everything solid you have ever known has been standing on it this whole time, without ever letting on. And there's one last piece, the most astonishing of all, and I'll leave it with you before we begin to turn toward rest. It follows from everything we've said, and it's simply this: nothing in the universe is ever perfectly still. Nothing, not ever. Because to be perfectly still would mean to have a perfectly definite position and exactly zero motion, both sharp, both pinned at once. And that is the one thing that cannot be. So even if you cooled something down as far as it could possibly go, colder than the depths of space, all the way to the coldest cold there is, where you'd think every last shiver of motion would finally stop, even there a faint trembling remains, a last irreducible hum that can never be taken away. Everything, everywhere, is always very softly in motion. The coldest atom in the darkest corner of space is still faintly trembling. It has been since the beginning, and it will be forever. And that same trembling is in you, right now, in every atom of your hands, your chest, the warmth of you against the sheets. You are humming very quietly, with a motion that will never fully stop, the same motion that stirs in the farthest star. The whole universe, down at its floor, is gently, endlessly alive. And so, all the way down, are you. I find this the most beautiful consequence of the whole thing, and I want to let it linger. We tend to imagine that perfect stillness is out there somewhere, that if you went cold enough, deep enough into the quiet, you'd reach a place of absolute rest, a total and final stillness where nothing moves at all. And what the uncertainty principle tells us, softly, is that there is no such place. It cannot exist. Perfect stillness would mean a thing pinned to an exact spot with exactly no motion, both sharp, both fixed, at once, and that is the one arrangement the world forbids. So the deepest rest the universe allows is not a dead frozen stillness. It's a gentle, endless, irreducible sway. The lowest note the world can play is not silence. It's a faint, warm hum that goes on forever. And maybe there's a small kindness in that for the way we think about rest itself, because we sometimes imagine real rest would mean stopping completely, every motion ceasing, and when we can't reach that, we feel we've failed at resting. But the universe shows us that this was never what rest is. The deepest rest there is, the rest at the very floor of the world, is not a dead stillness. It's a living, ongoing, gentle sway. You don't have to stop completely to be at rest. Nothing ever does. You only have to soften and slow and let the motion become quiet and small. I want to be careful here and honest, because I'm about to step from the physics into something softer, and I don't want to pretend the one is the other. Everything up to now has been the science, as solid as we can make it. What I'm about to say is just a feeling I've come to carry, a way this idea has settled into me over the years. Take it as one person's reflection, nothing more. Because think about what you actually are, lying there in the dark. You are a small, warm, temporary arrangement of the most astonishing stuff in existence, the same unpinnable, softly trembling stuff that lights the sun and holds the atoms open and never quite goes still. For almost all of the history of the universe, that stuff simply did its work, silently, with no one there to notice. The stars burned for billions of years, with no one to see them. The atoms held themselves open in the dark with no one to wonder why. And then briefly, in one small warm corner, some of that stuff arranged itself into a thing that could look back down into its own foundations, that could lie in a bed at the end of a day and actually grasp, even a little, how strange and how gentle the bottom of the world is. That's you. That's what you're doing right now. Let that sink in slowly, because it's easy to say and hard to really feel. The very atoms you're made of, the ones holding your hands together, keeping your heart's cells apart, humming with that endless faint motion. Those atoms are made of the same unpinnable stuff that lights the sun. You are not separate from the physics we walked through tonight. You are not a spectator who came to hear about it. You are a piece of it, warmed by a star that shines by this exact softness, built out of atoms that hold their shape by this exact refusal to be pinned. When you set your hand on the sheet, you're one part of the universe's soft foundation, touching another part. And somehow, impossibly, this particular arrangement of it has woken up enough to notice, to lie here and feel the wonder of its own strange makeup. The universe made a small warm place where it could look at itself and be amazed, and tonight that place is you. And I find that I don't feel small when I think about it, the way cosmic things are supposed to make us feel small. I feel the opposite. I feel the sheer unlikeliness of it, that there should be any warm, thinking thing at all, anywhere, briefly able to know that the sun shines, because reality can't be pinned down, and that its own hands are humming with the same motion that stirs in the coldest star. Because consider how easily there might have been none of this. A universe of soft, unpinnable stuff, lighting its stars and holding its atoms open for billions upon billions of years, and no one anywhere to notice a moment of it. That was very nearly the whole story. For almost all of time, in almost all of space, that is the story. Gentle, astonishing physics, unfolding in the dark, unwitnessed. And then here and there, impossibly, some of that stuff folds itself into an arrangement that can feel and know and marvel. A warm pocket of the universe that woke up. You are one of those pockets. For a little while, the soft, unpinnable world has, in you, opened an eye and looked at itself. That won't always be so. It wasn't always so, but it is so tonight. And that is about the most improbable and precious thing I can imagine being. Out of all the ways things could have gone, all the vast dark stretches of universe with no one in them to notice anything. Here you are for a little while noticing. That isn't a small thing to be. It's a staggering piece of luck. And notice that this is a gentler kind of wonder than the frightening sort of awe, the kind that makes you feel like a speck, lost in something too big and too cold to care. This isn't that, because the thing you're a part of isn't cold and indifferent at its foundation. It's soft. It's the gentleness that keeps atoms open and lets stars shine and never lets anything go perfectly still. You're not a lonely speck adrift in a hard, uncaring machine. You're a small, warm expression of a universe whose very foundation is a kind of softness, held by it, made of it, briefly awake inside it. That's not a wonder that shrinks you. It's a wonder that belongs to you, because you're made of the very thing you're marvelling at. And you don't have to do anything with it. You don't have to earn it, or make it last, or hold it tight. You only have to have it, this brief, improbable window of getting to be here and getting to know. And you do have it. Tonight. You made it this far, into a night where you could lie still and learn how a star shines. That was never guaranteed, and here you are anyway. Think of the distance we travelled to arrive back at something so simple. We went all the way out to a mystery that stumped the finest minds, a sun that shouldn't shine, and followed it down, through the strange third kind of thing that matter really is, through the wave that can't be pinned, down to the soft floor of the world. And what we carried back up wasn't a fright, and it wasn't a lecture. It was this, that the softness which lights the sun is the same softness that holds you together, and that you, briefly, get to be here, and know it. The long way out and the long way back, and at the end of it, only your own quiet room, and you in it, warm and tired, and improbably, wonderfully here. So there's nothing left to figure out tonight. The mystery we started with has been answered. The sun shines because the world is soft. You are held together by the same softness. And you get to be here, for a little while, to know it. That's enough. That's more than enough. You can let the wondering go now, gently, and simply rest inside the strangeness, held and warm and briefly, improbably here. You don't have to hold on to any of it. Not the physics, not the mystery, not even the wonder. You can let it all soften and drift, and it will still be true. The sun will still shine by it. Your atoms will still hold together by it, whether or not you keep a single thought about it. That's the good thing about a true wonder. It doesn't need you to remember it. It's only offered itself to you for a moment, tonight, as something beautiful to fall asleep beside. And now you can set it down, the way you set down everything else, at the end of a day, and let the softness it described do the last and simplest thing it knows how to do, carry you gently into sleep. So let's come back now, up out of the physics, into the simple room where you're lying, and let's let the whole idea do the quietest thing it can do. Let's let it hold you. Begin with your breath, because your breath is already doing this, already soft, already moving, asking nothing of you. Don't change it. Don't measure it. Just notice it, the way you'd notice a tide, the slow rise, the gentle fall, the quiet turn between. In without effort, out without effort. It has kept you all day without a single instruction, and it will keep you all night the same way. You can hand yourself over to it now. And as you breathe, let the day's sharpness begin to loosen. All that locating, all that keeping track, all the effort of holding yourself in an exact and ready shape. You can set it down. Nobody is measuring where you are anymore. For the length of this night, you're allowed to be as unpinned as the deepest foundations of the world. And there's a quiet permission in that, drifting up from everything we saw tonight. All day the mind works so hard to pin things down, to know exactly where you are, exactly where you're going, exactly how you're doing against where you thought you'd be. And the universe that made you, the thing you're built out of, does not do this. It cannot. At its very foundation, it holds its own position loosely, its own motion loosely, always a little soft, always a little in motion, and it is not falling apart for the lack of sharpness. It is held together by the softness, so you don't have to be perfectly located tonight, or perfectly sure of anything, before you're allowed to rest. The most stable things there are, the atoms that have held together since the beginning of time, are stable precisely because they never insist on being pinned. You are made of them. You can rest the way they rest, soft and a little in motion, and perfectly, completely allowed to be. Let your face soften first, the small muscles around your eyes, your jaw coming unclenched, your brow going smooth. Let it all settle wherever it settles, nothing held in any particular place. Let it move down through your shoulders and let them fall, heavier than before, sinking into the bed. Down through your chest, rising and falling on its own, no effort from you. Down through your arms, all the way to your fingertips. And remember, as they grow heavy and warm, that they are humming, very faintly, with that same motion that will never quite stop, the same motion that stirs in the farthest star. You are made of restless, glowing, unpinnable stuff, and it is settling now, going quiet, but never quite still. It doesn't have to be still to be at rest. Nothing in the universe is. It only has to soften and slow and hum more and more quietly in the dark. There's no map you need to keep of yourself tonight. No sense of exactly where each part of you is, held ready in the mind. You can let that map go soft, and then let it go entirely. All day you were a sharp thing, located, definite, tracked and timed and placed. That was the work of a day, and you've done it, and it's over now. Nobody is measuring where you are anymore. Nobody needs to know your exact position, or your exact speed, or where precisely you're headed. For the length of this night, you're allowed to be as unpinned as the deepest foundations of the world. Down through your belly, rising and falling. Down through your hips, sinking. Down through your legs, long and heavy, all the holding going out of them. All the way to your feet and past them, until the sharp outline of you begins to loosen and spread, like a little bundle of waves no longer needing to be pinned to a point. You were never truly a hard shape with a clean border. That was only the daytime picture, the sharp, located, ready version of you that the day required. Underneath, you have always been something softer, a vast, quiet gathering of trembling, unpinnable things humming together in the dark, and you can let yourself be that now. Not a sharp point of a person held in place, but a warm and gentle presence, spreading a little at the edges, no longer needing to know exactly where you end and the night begins. That line can blur, it's allowed to. Everything blurs at the bottom of the world. You're only becoming for a while what you always were underneath. And feel underneath you the whole astonishing thing holding you up, the soft foundation of the world, the same gentleness that lights the sun, keeping every atom of you open and whole. You are not lying on something hard and indifferent. You are cradled all the way down by the very strangeness we walked through tonight, held together this very moment by a universe that cannot be pinned down and never had to be. And there is a whole sky of it above you too. Every star you have ever seen is doing exactly what the sun does, shining by this same softness, this same refusal of the smallest things to be pinned. So the light of the stars, and the warmth of the sun, and the solidity of your own bed, and the faint trembling in your own hands are all the same gentle fact wearing different faces. You are held inside it on every side, lit from without by it, held together from within by it, made entirely of it. There is no edge of you that isn't part of this soft, glowing, unpinnable world. You could not fall out of it if you tried. You can only sink deeper in, towards sleep. There is nothing you need to locate now, nowhere you need to be exactly. You are here, improbably, briefly, wonderfully here, and here is soft and warm and enough. You can let the wondering blur into the dark. You can let yourself simply be what you are, a small, glowing, trembling piece of the universe, at rest inside the mystery it's made of, drifting gently down towards sleep. You don't have to follow the words anymore. Let them go soft too, and blur into the dark at the edges of the room. Just a sound now, a low hum, like everything else at the bottom of the world, never quite still, never asking anything of you. There is nothing to pin down, nowhere exact to be. The whole night is wide and soft, and yours, and there is more than enough of it. Somewhere out there, the sun is still burning. For no reason you have to understand tonight, warming a world you get to be a small part of. And you are here in the dark, held by the same gentle strangeness that lights it. If a thought drifts by, let it drift, soft-edged, unpinned, the way everything is down at the bottom of the world. You don't have to catch it. You don't have to follow it anywhere. Let it blur and pass like a ripple spreading out and thinning into stillness. There is nothing to hold on to tonight, nothing to fix in place, just the slow, gentle loosening of everything, breath by breath. Nothing is perfectly still. Not the coldest atom in the farthest dark, not you, just a faint, warm motion, going on and on, humming quietly, carrying you softly downward into sleep. You are made of starlight's own strange stuff, and you get to rest in it now. There is nothing to hold, nothing to solve, only the quiet drifting, and the long night, and the soft foundation of the world, cradling you all the way down. Softer now, and softer, like a little bundle of waves spreading out across still water, thinning, gentling, letting go of its shape. You don't have to be anywhere in particular. You don't have to be anyone in particular. Just a warm and quiet glow in the dark, humming its lowest note, held by the whole gentle universe, drifting slowly down. What a strange and lucky thing to be here at all, and now to rest, all the way, let it take you. The sun will shine tomorrow, held up by the same soft strangeness that holds you now. The atoms will keep you whole through every hour of the dark, asking nothing of you. There is nothing left to do, and nothing left to know. You can let the last of it go, and let the gentle, humming, unpinnable world do the last thing it knows how to do, carry you softly down into sleep. Softly, and still faintly glowing, and gone.